In this podcast, we'll review triangle inequality, and we'll also look at the exterior angle of triangles. So for the warm-up, which of the side length combinations will create a triangle? So remember triangle inequality, which is the sum of the two smaller sides has to be bigger than the biggest side. So I'm going to write that as an inequality. So the sum of the two smaller sides has to be bigger than the biggest side. All right, so let's check the sum of the two smaller sides. Here the two smaller sides are 1 and 1. So 1 plus 1 is 2. Is 2 bigger than 2? And no, it is not. 2 is equal to 2. So that would not stretch to make a triangle. So this would not make a triangle. All right, let's try the next one. Again, we're going to look at the sum of the two smaller sides. So 8 and 10. Oops. Is 18 bigger than the biggest side, 14? Yes. So the second one, these side lengths would make a triangle. 8, 10, and 14 could make a triangle. And the last one, again, add the two smaller sides, so 10 and 6. Is 16 bigger than 18? And the answer is no, it is not. And so then, again, 6 and 10 would be too short. You're trying to make a triangle. The sides would be too short. It might look something like that, so no. Okay. So let's talk about how big can the third side be if you have two smaller sides. So again, here's the inequality of two smaller sides add up to bigger than the biggest side. You can form a triangle. So here's the first example. If 2 and 7 are the lengths of two sides of a triangle, what's the range of possible values for the third side? So I'm going to draw a triangle. All right, so there's two ways to do this. Let's say that this was our biggest side right here. Okay, so if this is our biggest side, then we know that 2 plus 7 is 9. If this is our biggest side, then that biggest side has to be smaller than 9. Because again, 2 plus 7 has to be bigger than the biggest side. But let's say that 7 is our biggest side, all right? Then we have to think x plus 2, so what number plus 2 has to be bigger than 7? Okay, so we can solve this right here. So x has to be bigger than 5. Okay, so there's two ways to solve this problem. To find the smallest it can be, so I'm going to write this as a range of numbers. Your side can be between 5 and 9. Well, it has to be bigger than 5, but less than 9. So here's what the inequality looks like. Bigger than 5, smaller than 9. And to find it, it's very simple. You just add up your sides to get the bigger end. All right, so we did that here. And subtract your sides to find the smaller end. That's it. All right, so let's try another one. So let's say we have two sides of a triangle are 10 and 30. All right, so here's the inequality we want. X has to be between what two numbers? To find the two numbers, to find the biggest number, we add them together. So this one right here, we're going to do 30 plus 10 is 40. Okay, so our side has to be smaller than 40 so that when we add 10 and 30, it will be bigger than 40. To find the other end, you subtract them. 30 minus 10 is 20. So the side has to be bigger than 20 in order for a triangle to also work. Okay, so again, to find the range of values, you just add your numbers to find the big end, subtract them to find the small end. Example 3, if 5 and 8 are the lengths of the two sides of the triangle, what are the lengths of the third possible side? So again, here's my inequality. I know x has to be between two numbers. To find the numbers, we add and subtract. So here we'll subtract them. 8 minus 5. 3 is the smallest it can be. Actually, it has to be bigger than 3. And then here we add them. 8 plus 5 is 13. So x has to be bigger than 3 and smaller than 13. So you can do an example like 11. Would 11 work? And it does, because 5 plus 8 is bigger than 11. Oops. I just meant to erase this. All right, let's do one more. If blank and blank are the lengths of two sides of a triangle. Okay, so I was just going to have you guys make up numbers in class, so I'll just pick two numbers. Let's say 11 and 14. What is the range of values? So again, here's our inequality. Okay, it can't be lower than, we'll subtract them, 14 minus 11, 3. So x has to be bigger than 3, but smaller than 25. And then the side lengths will work in triangle inequality. All right, so there's the first part of today, finding the range of values that your triangle can be. And then the second part of the lesson is exterior angle. So you can see what an exterior angle is. It's the angle on the outside of a triangle. There's 3 interior angles, but 2 are remote. The remote interior angles are the one furthest away from the exterior angle. So remote means kind of far away. 3 and 4 are far away from number 1. All right, so the exterior angle is the angle on the outside of the triangle. The adjacent interior angle is the angle next to the outside angle. And the remote interior angles are the angles far away from, so angles not next to the exterior angle. Okay, so again, exterior angle, you got your 2 remote interior angles. All right, so it says find the missing angles and then make an observation about the remote interior angles and the exterior angles. Well, from triangle sum, you should know that this is 100. And then from straight lines, we know that this is, actually, this is not 100, I'm sorry. This should be 80, because now it adds to 180, which would make the outside 100. All right, let's do the next one. So if I take 180 and subtract 44 and 82, we'll get 54. And then right here, we know there's 180 degrees in a straight line, so 180 minus 44, that's 136. All right, let's keep going and then we'll look for a pattern. All right, and now 70 plus 80 is 150, and so this angle has to be 30. And then we have a straight line, so 180 minus 30 is 150. And the last one, we have 50 plus 53. We'll subtract from 180. This is 77. And then to find the angle the adjacent angle to the 53, we'll subtract from 180, and we'll get 127. So again, that was 180 minus 53. Okay, so the question is, what do you notice about the exterior angle and the 2 remote interior angles? So I'll circle them. Okay, so it's pretty easy to see in examples 1 and 3, and you can test it in 2 and 4. But what you should notice is the 2 remote interior angles, they add up to the outside angle. All right, so it's the 2 remote interior angles, the sum of those equals the exterior angle. So here's our conjecture for today. The measure of an outside angle of a triangle is the sum, means you add them up, of the 2 remote interior angles. All right, let's do a few examples. So again, if you forget this theorem, you can still solve the problem doing what we did. This is meant to be just a shortcut. And so if you remember the shortcut, you'll go a little bit faster. But again, you can solve all these problems without this shortcut and get the right answer. So here again, we have our remote interior angles. So x will be 50 plus 65. So here x will be 115. But again, if you didn't know that, you could figure out this angle first and then that angle. So you don't have to know this property. It's meant to be a shortcut. All right, let's take a look at this right here. So again, we could figure out r not knowing the theorem. We could figure out this angle and then subtract from 180. But let's just use the fact that r plus 58 equals 130 and solve. So we can subtract 58 from each side. So r equals 72. Okay, so again, all these problems you can solve without the shortcut. It just might take a little bit longer. All right, so here, these 2 add up to 135. That one you can't solve without it. All right, and then last example, whoops. So again, we know that these 2 angles together equal the outside angle. So we're going to add them up. 6x plus 17 plus 7x minus 1. Together, they equal 120. So let's combine like terms here. We'll add our x's. We have 13x. We'll combine our 17 minus 1 is 16 equals 120. And then we can solve. So we'll subtract 16 from each side. We get 13x equals 104. Divide by 13. And we get 8. Okay, and then go back and read the question, make sure it's what they're asking for. it says solve for x. We did that. And then find the measure of each angle. So now we have to go plug back in here. So let's do that. So this one right here would be 6. And we know x is 8, so 6 times 8 plus 17. Okay, so that is 65. So this is 65 degrees. And then 7x would be 7 times 8. Oops. Minus 1. And so that's 56 minus 1, 55. And then to get the last angle, either add them up, subtract from 180, or just do 180 minus 20, 120, and you'll get 60. All right, so there it is, the exterior angle theorem. The two remote interior angles equal the outside angle.